Let's look at these notes on parallel lines. Just as a review, graph the following lines on your calculator at the same time. So if you graph y equals 3x plus 1, y equals 3x minus 3, and y equals 3x, put them in your y equals, and then hit graph and see what you notice. And what you will notice is that all three lines go up like that. One line goes through 0, 0, one goes through 0, 1, and one goes through, that one's going to go through -3, so actually that one's going to be down here. So the lines have something in common. One thing, they all have positive slopes. And what are the slopes equal to? Right, they all have slopes of 3. Do you notice anything special about the lines on your graph? Do they intersect? The lines they do not intersect. They do not intersect. Do you think they will ever intersect? Why or why not? No? Right? Because, why not? They have the same slope. Good. They have the same slope. The lines above are called parallel. P-A-R-A-L-L-E-L. Parallel lines have the same slope, but different y-intercepts. Why do you think they need to have different y-intercepts? Right? If it had the same slope and the same y-intercept, it would be a line on top of a line, which means they would definitely touch. They would be the same line. They would have infinitely many solutions, okay? It would be a line on top of itself. Graph y equals 2x plus 3 on the grid below. So we can use this grid to graph that. I'm going to have to move this up a little bit for you, so I'm going to go ahead and erase all of this, and we're going to get to the part where we can look at the grid. Okay, let's look at the grid. What is your slope here? Good, 2. And your y-intercept? Right. So graph a line that is parallel to y equals 2x plus 3 that goes through the point -1, -4. So when they give you that situation, your point is where you start on this line. So we're not graphing that line, else we would start at the y-intercept of 3. We're going to graph the line that's parallel to that. So we go to the left 1 and down 1, 2, 3, 4, and that is your starting point. Now you want a line that is parallel to y equals 2x plus 3. So what do those two lines have to have in common to be parallel? A slope, right, a slope of 2. The slopes have to be common, so the slope of the second line must be 2 also. And 2 is the same as a rise of 2 and a run of 1. So we rise 1, 2, we run 1, and we put a point. Rise 1, 2, run 1, put a point. And then you can draw your line. So you have this line that is parallel to y equals 2x plus 3. What's the y-intercept of this line? 0, -2. So our y-intercept is -2. So the equation in slope-intercept form is y equals mx plus b, which is -2. And what I can also do is just go ahead and show you that other line so you can see the parallel lines. That other line has a y-intercept of 3, so we would start at 3. And then you have your rise over 1, which is 2 over 1, up 2 over 1, up 2 over 1. And then you can draw your line through these points. And now you see your parallel lines. In a system of linear equations, if I had these two equations, y is equal to 2x plus 3 and y equals 2x minus 2, and I asked for a solution, I would have no solution, because a solution is where these two lines cross. But since they are parallel, they never cross. So the answer would be no solution. Now let's look down here. Explain your answer for each of the following. The lines y equals 2x minus 3 and y equals x minus 3 are parallel. What do you have to look at to determine if those two lines are parallel? Right, their slopes. This has a slope of 2, this has a slope of 1. Are they parallel? Nope, right, different slopes. So they're not parallel. The lines y equals x and y equals negative x are parallel. Yes or no? Once again, no, right. This has a slope of 1, this has a slope of negative 1. Not the same. So false, again, because they have different slopes. Lines that have the same slope are parallel. That's true if they also have what? Right, they also must have different y-intercepts. The lines y equals 1/2 x minus 4 and y equals 1/2 x plus 2 are parallel. The slopes look to be the same, so that might be so. Then you check out your y-intercepts and they look different, so yes, that's very good. It works because they meet the conditions of lines in order to be parallel. Number 5, graph and write the equation of the line that is parallel to y equals 3x plus 3 that goes through the point -1, -4. We'll use this grid up here. I believe you have one on the bottom of your paper, but since I have a grid here that's very accurate, we'll use that. So now what we are doing is we're taking number 5, so we're going to take, this is number 5 now, and we're going to graph it on this grid. So first of all, let's go ahead and graph this 3x plus 3. Where do you start with y equals 3x plus 3? Right, 1, 2, 3. What's your slope? Yes, 3. So you rise 1, 2, 3, you run 1. Rise 1, 2, 3, run 1. Or down 1, 2, 3, left 1. And then you can draw your line through those points. That's the given line. We want to graph the line that is parallel to this. So what does the slope of that line have to be? 3? I agree. Same slope, m equals 3. And we want to cross through -1, -4. So we go left 1 and down 1, 2, 3, 4. And then we're going to use our slope of 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And we draw the second line. Oops, not beautiful. I'm going to do better. And I have a ruler. I can do better. Okay, so here's the line. Now we want to know the equation of this line. What do you need for that? Your slope, good. We have our slope of 3. What else do we need? Good, your y-intercept. And what is the y-intercept here? So we have to see where this line crosses the y-axis. So I'm going to erase the line that we were given to begin with so you can just only look at the line that you need to look at. Well, the y-intercept is right there. What ordered pair does that correspond to? Good, 0, -1. So your y-intercept is -1. So your answer is y is equal to 3x minus 1. And you can also check that algebraically. You will use x is equal to -1, y is equal to -4, and slope is equal to 3. I can do that for you also, so you can check yourself. So we're going to have y equals mx plus b. Let me just scroll up so I can use that bottom piece now. And then I'll erase. Okay, let's do this. Algebraically right here. So we have our x, we have our y, and so y equals mx plus b. Let's see. Y is negative 4. M has to be the same, which is 3. X is negative 1 plus B. Negative 4 equals negative 3 plus B. Add your 3, because you're very good at solving equations now. B equals negative 1, so we have Y is equal to 3x minus 1, which is what we said. Go ahead and try number 6. Come to me after you've done number 6. Let me know if you have any questions, and I will help you out.